All right, so what do we think is, you could say any of it's confusing. What we want to think about is we had mentioned student-based review. Well, all right, so you start giving me the words to write down, and we will. And you can't use a prior problem as an example. It is about what? The acres? The tractor? The corn? The corn. What about the corn? What do you mean is this bonus questions? Okay. Farmer Grace. Farmer Tom. And Farmer Cole. Okay. You've got a van. I don't think so. Let me look at a couple things here. Okay, so you had the right idea, Tom, but it was the wrong crop. It's actually soybeans that put nitrogen back into the soil. And oddly enough, I think the Department of Agriculture is saying that more farmers are going to plant corn this year as opposed to beans. Now, whether that's going to be accurate, I mean, you're looking at agriculture futures here, but maybe yes, maybe no. It's all about fertilizer. Okay, that's what we're going to say. So, if ammonium sulfate is produced from the reaction of sulfuric acid and, I believe, ammonia. Okay. What is maybe the most difficult part of this? Is it one of the things that we had said long before when this semester had started? We're trying to give you a fair warning in, let's say, late November and December. We said when you get to stoichiometry and gas stoichiometry, when it comes to this, if you don't get it right, it doesn't matter what you do from there on out, it's going to be wrong. So is it the reactions that might be the toughest part, or what do you, if it's written like this? Okay. So we don't have enough information right now unless we put one term and a number up on the board. It starts with S and ends with P. Okay? So at STP then, remember that's your friend. That makes things a lot easier. Now, can you use the ideal gas law if it's at STP? Yes, you certainly can. Okay? So if it's at STP, do we want to find a mass or a volume? Okay? So at STP, we're going to say, okay, so let me think about this for a moment. We'll go 15,000 grams. Okay. You said, do you want to look for a volume or mass? And you said mass. Okay, then this is what we want to do then. Okay. So at STP then, we'll say 12,000 liters of ammonia can produce how many grams of ammonium sulfate. Okay, so you have to extrapolate what this reaction is. So we'll put some general terms up there to kind of help fill in the gaps here so we can get that reaction correct. So ammonium sulfate, what would that be? What's ammonium? Okay, so that is NH4. Okay, what is sulfate? SO4. Okay, so sulfate's a -2. Ammonium is positive what? +1. These charges don't add up to 0. Okay, so we've got that NH4. Said you needed 2 of them. SO4. Okay. What's that ammonium? Whoops. Well, we can just say it's going this way. Okay. So that's what's being produced. What is it that's reacting to cause that to be produced? What's sulfuric acid? H2SO4. Okay, so what is that reacting with? What is ammonia? So if ammonium is NH4, ammonia NH3. Okay? All right. So now we've got our reaction, and we'll come back to this in just a moment. What is the next thing we should do when we see that we've got a reaction? Okay, so maybe it's already balanced. We don't know. No, and it's really not that difficult. It just looks like it's, if I'm perceiving, I just tried to quick do it in my head, and I think it's right when I look at. I believe that would be correct. So if we put a 2 here, let's just double check things. Nitrogens, we've got 2 and 2. Okay. Sulfurs, we've got 1 and 1. Oxygens, we've got 4 and 4. Then hydrogens, we've got 2 times 3 plus 2 more. And then 2 times 4 is, all right. So now we have to have a place to start, and that is with which number? Okay, so we've got 12,000 liters of what? Okay, so we've got 12,000 liters of ammonia. So what we're doing is changing this 12,000 to what? X amount of grams of that. Okay. Actually, I'm going to move that down just a little bit. 12,000 liters of NH3. Okay. So, how are we going to convert this volume to a mass? Well, let me ask you this. Do we have any ideal gas law people out there? Okay? So I hear no, a no, and a no. All right, so we need to get rid of this leader. Okay, so leaders in our next step would possibly go where? Okay, so we're going to put liters of ammonia down here. Okay, so we must be converting this. If we converting it to milliliters, no. We're not converting the volume. We're trying to get from a volume to a mass, which we can do because of this right here. Okay? So what presumption can we make when gases are measured at STP? How many liters do we have for every mole? Okay, so we got 22.4 liters of any gas measured at STP gives us a what? Now you're home free. Now it's just crunching the numbers. Okay? Well, crunch away, or you just want to keep working on it together? I mean, you tell me. This is for your benefit. Now, I'm just going to give a rough estimate here. It's not going to be exact. Is that, now that's just going to be an approximate number. Okay. Now, the reason I said this is just going to be an approximate number is what did you get for a mass of ammonium sulfate? I put about 132. That's probably where the numbers are off just a little bit. Okay? So, to make sense of this, as we continue, okay, we're all getting somewhere in that vicinity. So we're in moles of ammonia. What's the next thing we want to do with this conversion factor? With moles. Well, I don't know what that something is. That's what you got to tell me. You keep this up, people, I'm going to turn Rush on. He'll straighten you out. How do we get rid of this mole here? What's our next conversion? Okay, mole of what though? Are we having spasms back there or what? We're all going like this. Okay, so as we go back to this, there's a 1 there, so we've got a 1 there. We've got 2 here, so we'll put a 2 there. Now, okay, okay, so now when we do that, 12,000 times 132.17, divide that by 44.8, 35,402, right? Okay, so one thing to keep in mind, I know we say, well, we came close with our answer. This is just what it is we're talking about. Look, when you just put in 132 for this as opposed to 132.17, look at what the difference is we got 35,402, okay? So that's a difference of what, 42, so somewhere around, yeah, around 45 grams. Now, with a number that large, it'd probably be minuscule in this reaction, but some chemical reactions do have to be really, really precise. Now, is this one of them? That I really don't know. But I think sometimes what happens is we look at this terminology here and we think, oh my gosh, I don't know what sulfuric acid is, I don't know what ammonium sulfate is, but when you start breaking that down into the associated parts, it's really not that bad, providing you know what your acids are, because those are a lot of the common reactions that we do. So for instance, if you had hydrochloric acid, if it's just the chloride ion, which has a charge of what? Okay, and then that means how many hydrogens do you need? 1. If you have sulfuric acid, that means you have hydrogen sulfate, which SO4, as you had already said, is a -2. So that means you need how many hydrogens? 2. And then if you had phosphoric acid, okay, that means you have PO4. And PO4 has a charge of negative what? -3. So how many hydrogens would you need? Right, 3. Now, what happens is you could have hydrogen chloride gas. That's different than hydrochloric acid, because that means you have that suspended in an aqueous solution as hydrochloric acid. Hydrogen chloride is a gas, or hydrochloric acid is a solution, an aqueous solution at that. Okay, so to me, if you understand that, I think you're all right. So left side, middle, right side. Yes. You'd have to, let's say, maybe something in degrees Kelvin. What would happen if this was not a STP? You would have to be given a pressure in atmospheres. Okay? You would have to be given a volume in liters, which we had, that variable of 20 or 12,000. Of course, this is a given, and then finally you'd have to be given the temperature in degrees Kelvin. What variable are you missing here? Yes, so what would happen is with all 4 of these variables, your pressure in atmospheres, your volume in liters, and your degrees Kelvin, okay, you would solve for, would you solve for moles of ammonium sulfate, do you think? Ammonium sulfate is a solid, okay? because ammonia is a what? Is a gas. So that means you solve for moles of ammonia here. Then, just like last or 2 chapters ago, once you're given an amount of a substance in moles, in 3 steps you could convert the moles of ammonia into a mass of that solid.
So when we're given a pressure and a temperature, it's always towards what we are defining.
Yes.
Okay. Gotcha.
Okay. Any more discussion over this problem? Otherwise, that's where we will stop for today. So there's 2 parts. With that, the individuals who are gone, they're going to have to take part of that tomorrow. And then some individuals will be gone again on Thursday because of track. It's where you're going to have to start filling in the gaps. So one of the things that we can and sometimes do is we will just put it in as missing, and maybe that will be a motivational factor to get in and get that completed. Zeros tend to put you could say, a weight around your ankles as you're jumping in the water and pull you under. I mean, can you recover from that? Yeah, but you're really making it difficult on yourself if you have any zeros in the grade book. That's a law of averages would tell you that. Okay, so we will catch up with you next time.